Welcome back, everyone. Our next presentation kicks off a couple of sessions around dyeing and finishing in the industry and how we can lower emissions in this area of the value chain. Textile dyeing and finishing processes are some of the most polluting manufacturing processes on the planet and are responsible for over 3% of the global CO2 emission and over 20% of global water pollution. If nothing changes, CO2 emissions from textile dyeing are set to reach 2.5 gigatons by 2050. Dr. Alan Hudd, director and founder of Alchemie Technology, a technology company that has created a digital dyeing method that significantly reduces the amount of water and chemicals used in the dyeing process, thus helping brands achieve their ESG targets. Alan, thank you for joining us. And over to you for the presentation.
Thank you very much. And just to put the 2.5 gigatons into perspective, that's equivalent to the emissions of pretty much Northern Europe, France, Germany, Belgium, Holland, Netherlands, all those countries put together today. So that's what we're looking to reduce over the next period, next 10 to 15 years, 2.5 gigatons. Okay, hang on, I need some. Just think we could be in Dubai. So, okay, are we good? Can we see that? I guess so. All right, so thank you very much for giving me this opportunity to speak, and don't know who's out there, but it's really a pleasure to talk to you about what we're doing. So we've been on a 10-year journey to create a commercial proposition to significantly significantly reduce emissions and eliminate the use of fresh water in the textile industry, and that's what I'd like to share with you today. So we're a Cambridge-based company, just south of Cambridge, and as I say, we've been spending a great deal of time creating our own digital technology, a little bit like inkjet, but in details very different, to enable us to create a clean tech solution for dyeing and finishing textiles. Chinky said that the state of the textile industry in terms of the problem, and it is significant. So dyeing, the industry contributes to today approximately 10%, maybe even more, of global emissions, and the dyeing process accounts for at least 3% of those emissions, and it is the second largest cause of global water pollution. So it uses a lot of fresh water in the process of creating a dyed fabric, and maybe we'll get into some of those points in a second or so. So these are real pictures, real images of visits to Southeast Asia. So this is the damage that the textile industry is doing to rivers by using this fresh water and then polluting it with toxic chemistry, and then the honourable companies treat their waste, and maybe less honourable just dump it in the river. I mean, increasing government regulations are pushing towards treating wastewater. So it's quite interesting, really. Water, we talk about 2030, there's going to be a demand 40% greater than supply. But really, if you look at planet Earth, then the amount of water available to us has never changed. It's all about access and availability of fresh water. And that's the big problem. And that's the precious commodity, actually using this fresh water that is available to us. The total amount of water hasn't changed in the history of the planet. So it is really all about access and availability to fresh water. I can't see half my slides. What's going on? Excuse me a second. Yeah. So water scarcity is really an important threat to us all on this planet. And if you imagine a ton of polyester black dyed polyester, then it generates 30 tons of wastewater, highly toxic, polluted water. And to put that into context, the textile industry is using over 1.5 trillion liters of water a year. And as I say, we're using all this fresh water, and therefore the demand is going to outstrip the supply if we don't do anything about it. And again, these are real images. Be shocked if you're not aware of the workings of the textile industry. So behind all these brands, behind all of the fashion industry, behind all of the apparel, then sits a very dinosaur industry. A dinosaur industry that uses processes that were created over a couple of hundred years ago. And those processes of dyeing fabric were no longer acceptable in the UK 200 years ago. It got shipped to the USA, the textile industry. It lasted 20 years in the USA. And then it went to China. And over the last 50, 60 years or so, China and Southeast Asia has been enjoying tremendous wealth from the textile industry. But the consequence of all of this is really the damage it's doing to the rivers, to the global emissions. So there is an element in the West of governments saying it's not our problem, these problems are created in Southeast Asia, but it's not true. It's a global problem. You know, it's just because it's maybe not in our own backyard. We're all suffering the consequences of damaging this planet, especially through emissions. So we, as I say, we spent 10 years developing this technology. And the top left-hand image you see there is really our product called Endeavour that is all about dyeing. And the image below is a rendered image of Novara, which is all about finishing. And I'll just focus on digital dyeing for this presentation. So we pretty confident our claims stack up to scrutiny. And in the case of polyester dyeing, we're pretty much saving 85% energy in our digital process, and we're certainly doing better than reducing the amount of wastewater produced by at least 95%. And what comes with all of that is the reduction in toxic chemistry, because we're only using the right amount of dye to dye the fabric and not an excess dye that the traditional process uses. And because it's effectively, to coin a cheesy phrase, it's an AI solution, then we're using less labor and we're using technology to convert it to a clean tech process. So that's really our solution and claims. And this is an image of our typical configuration. So because polyester is hydrophobic, we duplex dye the polyester. In the case of cotton, because it's hydrophilic, we certainly only need to dye from one side, because it certainly likes water and we're able to do it. So the process is we take a roll of fabric, we send it through our Endeavour machine, we jet, non-contact jetting onto the fabric on the top side. We then dry the top side of that fabric, by which time the inner of the fabric has been penetrated. We loop it around, dye the underside, dry it again, and then in the case of polyester, we dry heat fix it. And then because we've dry heat fixed it, then some of the fibers become a little stiff as they stick together. We put it through a softening unit, to really agitate that fabric and bring back the hand, and then set and dry it. So that's our polyester process. Our cotton process is similar, except we only need to dye on one side, and of course we use steam fixing with reactive dyes. And the image on the left is really the heart of the technology. It has taken us 10 years to validate. And the point is that little device, as you can see, it's about 30 millimeters or so long, is equivalent to an inkjet nozzle. And the development of the product is all about taking that inkjet nozzle, putting 3,000 of these little inkjet nozzles into our product to create the solution, and then you've created a product that weighs 10 tons. So from 25 grams to 10 tons, and it works. It works exactly the way inkjet works, if you're familiar with textile inkjet printing, in the sense that we use a piezo crystal to resonate the fluid, and we send a pressure wave through the fluid, and we arrange it such that our nozzle is shaped, where we get a massive amplification on that resonance. And what that does is it draws fluid onto the tip of that nozzle and then fires it onto the fabric. And the reason we're able to penetrate the fabric compared with inkjet is our drop size is much bigger, and we're able to sustain the velocity. So it's a little bit like inkjet is throwing feathers into the atmosphere, into the air, whereas we're throwing cannonballs at the fabric. And so this is operating at 184,000 times every second. We're resonating that tube, and we can produce a very discrete range of droplets onto the fabric to achieve very high color consistency. And so our product is producing about 270 million droplets, all identical volume, shape, and size. These droplets are about 10 break up into 10 micron diameter drops, and that's been specifically designed so that we can get in deep into the fabric and coat all the fibers. And that's a feature of the technology that we set out to achieve, and why it's taken so long. And so in comparison, on the left-hand side, you have inkjet, very small drops, economically not possible to dye fabric, and technically very difficult to dye fabric because your drops just end up on the surface and don't penetrate the fabric. Our drops are a nanoliter in volume, so they're like big drops flying to the surface. And as this big drop flies to the surface, it breaks up into very small identical droplets that give us this 10 micron droplet size to penetrate the fabric. And then on the right-hand side, we got the comparison with spray. So the problem with spray, because I have to find the problem, is that it produces a range of droplets, very difficult to control, but it has its place because it's cheap. Ours is a low-cost method compared with inkjet, but very, very precise. And that's the difference between spray is not very precise. Our technology is precise. Inkjet is super precise and too sophisticated for dyeing of textiles. Here's a little bit of proof just to add some authenticity. So you can see the fabric is completely dyed, not only on the surface, but also all the way through the fabric. And that's for a hydrophobic polyester material, which is quite difficult to get a water to penetrate polyester. And the big thing is we're doing this in seconds rather than in a bath at 130 degrees centigrade for 4 hours or whatever it is. We're doing this with the right amount of dye, no excess dye, so we don't have to wash it. We do not have to wash polyester after we've dyed it and fixed it. And therefore, We don't have all of that energy consumption associated with those post-dyeing processes. And that's where all the big energy savings are coming from. There's nothing special about the energy we're saving in applying the dye, but it's all about eliminating those post-processes that consume huge amount of energy and produce a huge amount of wastewater. Anyway, that's what it looks like. It's as I say, at least saving 95% of wastewater, which is a huge cost and a huge problem from a sustainability point of view. And we're saving 85% less energy by selectively putting the right amount of dye onto and into the fabric. And as a consequence of that, we're saving probably 30% chemistry, toxic chemistry. The system itself can use any chemistry. So it doesn't matter whether you want to dye polyester, cotton, blends with elastane, blends of polyester and cotton, or nylon. It's just all about using and selecting the right chemistry. So acid dyes for nylon, dispersed dyes for polyester, and reactive dyes for cotton, as an example. We can also use pigments, and gradually pigments are improving as time goes on. And the disadvantage of the hand, the stiffness of the fabric as a result of using pigments, is gradually getting better and better. And we can use pigments in this solution. And using pigments in the future will, of course, reduce the amount of energy even more, because we won't have these post processes to worry about too much. So here is a short video. I hope you can't hear it, actually, because it's noisy. And that's the Endeavour system: dyeing, infrared drying, looping around, dyeing, drying. And then when you come out, you can see the fabric dyed. It then goes through a fixation unit, a very neat fixation unit, comes out of the fixation unit, through our softening unit, and now you've ended up with completely dyed and fixed fabric, ready to be converted into whatever you want to convert it to. So it's as clean as that. So you can see the comparison between the traditional process, where it's a absolutely horrible environment to work in and to use, and this is very much today's solution that is a clean tech solution. Okay. So when you look at the market, this is a massive opportunity. We certainly understand it's the number one priority for brands, sustainability. There's no doubt about that. The textile industry consists of thousands of different applications, each requiring a little bit of optimization to address it. And that's why we are focused on polyester woven. We have a production unit in Taiwan operating today, currently on its initial production runs to supply brands with digitally dyed fabric. In this next year, we're going to productionize our woven cotton, and then knits with cotton and polyester. So within the next, let's say 12 months, we will be able to do, we will be in production, in the field, in the market, running production, dyed fabric for polyester woven, cotton woven, polyester knits, cotton knits, and any blends that you care to look at. Massive market, collection of different applications, got to focus on each application, and that's the strategy and the approach we're taking. So absolutely no doubt that all the brands have now got declared their targets reduction in fresh water, reduction in greenhouse gases emissions, and we're here to help brands. You know, the relationship in the industry is not that cooperative, and so we see ourselves helping to both sides, helping the brands achieve their ESG targets, and helping dye houses achieve much better productivity, reduction in costs, return on investment that is more acceptable. And as I say, it's not really a cooperative industry. Quite often you're swimming with sharks. What people tell you is not necessarily right. Brands and suppliers generally fight, and that's the historical pattern anyway. And so, you know, if we're really serious about making this change, that somehow we got to break this non-cooperative triangle. And so we've decided we really want to emphasize on helping our brands, making sure we can create for the brands the LCA data that proves the sustainability, the economic data that proves the return on investment, production quality samples, so that the brands are much more confident that they're able to tell their suppliers that if they want to supply a brand, then they have to meet certain ESG targets and certain cost targets. And we are probably one example of a few companies that might be in the future able to help dye houses achieve these targets for brands. So, you know, you can either be gloomy or optimistic. I'm optimistic, although it may not sound like it when I tell you that 1.5 is a lost cause in terms of temperature rise from pre-industrial times. We're currently, if you listen to COP28, currently on 2.7 or something, or 2.3, something like that. This is if we don't act now, and we leave it literally a few years, if we don't make real big inroads in the next 10 years, the planet is going to suffer dramatic changes, you know, because the time lag between bringing about a change today and the lag on the impact on the planet is about 150 years. So any improvement we make now, it's really going to take 150 years to stabilize the planet. If we really let this get to 3 degrees, then there's going to be real problems. And we face the reality that in 400 years' time, maybe there is no more planet. And all we'll find is tigers on the Antarctica, which will become a tropical paradise. So it is really super important. We don't think there's some magic fix and we can carry on as we are. It's super important that we try and act now and make these changes. And if we can, then life is going to become less intolerable to future generations. And I guess it's in our hands. So we seriously have to take sustainability into account as well as profitability of a company. And there are certainly some leading lights as far as brands are concerned who understand and are acting on that today. So that's good, but we need to do much, much more. And we need governments to intervene, and we need governments to invest. If you look at the venture capital industry, then, you know, last year, a lot of technology companies lost their way because the investment community went away. 51% less investments in technology companies last year. Of that 51%, 40% of those investments went into AI, 25% went into healthcare, and only 10% went into real climate change technology. So, you know, what's the point of living longer and creating all these good things from AI and healthcare if we've got nowhere to live in the next 150 years? So we really do need to make a change. We're also, if I just focus on the right-hand side, so we're coming out of that blue circle, blue circle. So every new technology, every company goes through this. And we've spent a great deal of time and a great deal of money getting from this initial early adoption, technology looks promising, to a really robust industrial solution. So we're just coming out of this having spent a great deal of money, a great deal of time, making sure we've got something that is sustainable and can deliver a truly clean tech solution in the future. But we need everybody's help. We need to focus on the real problems when it comes to sustainability. You know, textiles is far worse than global aviation and maritime put together. So although Greta sentiment is correct, focused on the peripheral edges of all of this, it's the industrial processes that are causing the problems. It's buildings, it's cement, it's food and packaging, and it's certainly textiles. They're the processes we really need to bring about massive changes. And you know, there's a prediction that we need $20 billion every year for the next 10 years to clean up this industry that we're in. So it is not without its challenges. And of course, governments and regulations can help. And upcoming next year, we've got the European regulations that really are now going to start taxing polluters. So, you know, maybe the problem is in Southeast Asia in terms of the pollution and the energy consumption. But if a brand is now going to export from Southeast Asia into Europe after next year, then the European Union is going to start taxing the effect of that pollution caused by that product. Anyway, so that's, I think, all I really wanted to say. And so our strategy is all about cooperating, supporting brands, trying to help dye houses in terms of their productivity, lobbying governments to bring about these regulations and changes, and educating the younger generations who are no longer going to tolerate these problems. And so we're very optimistic, and we're very confident that we're in a position now to really help the textile industry change and become much more sustainable. So if you're still awake, thank you very much. I'll end there.
Thanks, Alan. That was a very interesting presentation, and we've got some questions from the audience. So I'll start with audience questions. The first question is, do you plan to sell the technology to dye houses, or will Alchemie be the service provider?
We're planning to do both, to be honest. Initially, we see we have to get the brands on board. They have to be convinced. We want to convince them. We have to go through a process of producing real production data on LCAs and economic returns. Once that's achieved, going into the supply chain, into dye houses is going to be easy. There's a sticker shock involved in buying hardware, big capital hardware. We want to make that as easy as possible by maybe going through a leasing or a subscription process to dye houses. And then for those dye houses that are pioneering and understand that they really want to make a big change, we're interested in partnering with these big dye houses and maybe setting up dye houses in a partnership. But that's maybe the second step. The first step is really to get brands on board so that they're confident to tell their suppliers, their dye houses to adopt this technology. But if a dye house wants to work with us, we are all ears, and we will get into a partnership and sell the service.
Interesting. You mentioned about the cost comparison because there's this upfront hardware cost involved. So there's a question linked to, because you were comparing the technology with inkjet and your technology and the spray dyeing. In cost comparison, where does your technology fit? Like, can you compare it, give some comparison with the inkjet technology?
Oh yeah, inkjet is prohibitively too expensive for dyeing. I mean, the problem, I come from the inkjet industry. I spent 35 years in the inkjet industry. So I'm a big ambassador to the inkjet industry. And the inkjet technology is fantastic, but you have to choose the right application. And quite soon into Alchemie, it became clear to me inkjet was not going to solve this problem. You know, you have a print head that might cost $5,000. You have one nozzle out, and you've got to get another print head for $5,000. And by the time you put an inkjet system together to dye fabric, it's a huge cost. You're talking many, many millions of dollars. So we're considerably lower than that because we've developed a technology where you can replace nozzles very, very low cost. So you don't have those sensitivities or limitations with inkjet. So from a cost comparison, we are going to our return on investment is going to be much better. We estimate, depends on the territory. You know, the China dynamics is different from Europe dynamics and Turkey dynamics. But our return on investment generally is somewhere between 18 months and 24 months from a hardware perspective, and take into account of all the savings. But as I say, we understand that still a sticker shock for an industry that needs to change rapidly, and that's why we're working hard to create easy ways for dye houses, for suppliers of brands to adopt the technology. And to be honest, once you work out subscription and leasing programs, then the amount of money you save compared with the old process pretty much pays for adopting the technology.
Going back to your presentation where you talked about the different types of fabrics and dyes that can be utilized in this technology, there's a question around pigments. They're asking the softness that can be achieved using alchemy technology, using pigments. Is there a comparative study that you've done with the traditional dyeing methods?
Yeah, so there's no silver bullet with any of this, is there? So the properties of the dyed fabric really come from the colorant you use rather than how you apply it. So where we are today with pigments, generally, maybe some of the pigment suppliers might have an issue with what I'm about to say, but generally using pigments today creates unacceptable hand feel for apparel. Probably okay for some applications like interior decoration, furniture and curtains and things like that, drapes. But for apparel and the fashion industry, then it's probably not up to what is required. But improvements are happening all the time, and I think it will get there. We have an active pigment program, and part of our active so the issue with pigments is you have to have a certain binder to pigment ratio to get the durability. The trouble is, the better the durability, the more binder you have to put in, and it's the binder that creates the stiffness in the fabric. So we are, because of our digital process, we can separate those two conflicting properties, and we can separate the binder from the pigment in order to maybe get a much better hand. So there needs to be two steps to go forward: improvements in the in the formulations and the performance of the binder to pigment ratio and how we do that, and also maybe we can adopt a more flexible process to get the durability and the hand through our digital process by separating those two conflicting properties.
Okay.
I can see I didn't explain that very well.
No, you did. Another questions come on that.
Right.
So you've talked about woven fabrics. Have you tested this technology on non-wovens?
Oh yeah, non-woven's fine. Woven's fine. Knits, we can do knits. It's all about the transport system, making sure you can control the tension of a knit, and that's the critical part in being able to do the whole range of fabrics. Yeah, the non-wovens, wovens, knits is really our game.
Okay, perfect. Because the conference is focused on decarbonization, I want to ask one question. How would you compare your technology to other dyeing technologies in the market in terms of carbon emission? Because we've talked about water, we've talked about chemicals, but from carbon perspective.
Yeah. So our decarbonization comes from removing all of the post processes. So in a process of dyeing, you're using a huge amount of energy heating the water, keeping that water at a very high temperature for a long period of time. That's a huge amount of energy. We eliminate all of that. So that I'm comparing that with jet exhaust dyeing. And then when you need to wash all of the excess dye from that jet exhaust dyeing, you're again using lots and lots of energy, and we eliminate all of those energies. Any technology that eliminates this use of having to use excess dye and high temperatures is going to be an effective technology for decarbonizing the industry, and that's what we do. There are other technologies that I think are trying to do the same, and I wish them well, and they will also have a very effective result. Incremental changes, so there are some companies that are suggesting they're proposing sustainability, but really they're not cutting out the energy consuming parts. It's an incremental change. Ours is a big step change. I'm not saying we're on our own, but ours is a big step change. And so there is a lot of hype around sustainability. And if we're gonna clean this industry up, we really have to make a big step change. Fiddling around at the edges, as a few companies are trying to do, isn't really going to cut it when it comes to reducing emissions to the levels that the brands want to achieve. So we think we're leading that process of decarbonizing. We believe so. I don't think we're on our own, but I think we're leading that process.
Brilliant. And in terms of the barriers to adoption, you talked about pricing, the hardware costs specifically. But since we know the EU Green Deal is coming, then there's legislation coming in the US as well. But the manufacturing countries are away from this. Those who want to work with the European brands and US brands will have to adopt to newer technologies. What's the funding process? If someone wants to buy into your technology, do you think the best way is to collaborate with a brand? So you convince the brand regarding this tech?
If a supplier is exclusive to a brand, if a dye house is exclusive to a brand, that's probably the best way to involve the brand in such a cooperation. If a dye house is a multi-brand supplier, then we would love to talk about a partnership with them to create a clean tech dye house with them. And the funding, we're trying to make sure that the funding doesn't become a barrier to entry. So we've just raised We've just raised sufficient capital to allow us to get credibility in the marketplace. And part of that is to have production systems in Taiwan producing real production in 2024, production in Bangladesh producing real production of cotton in 2024, production in Europe in 2024 for cotton and woven and knits. So that's funding shouldn't really be an issue.
Brilliant. I think we're on time now, but I do have one last question, which is around the company's future plans. Are there any new product launches or any incremental changes that you're planning to launch in the near future?
Our program goes out a long way. We're not in this for the short term. We're on this journey to bring about the change in the textile industry. So if we start with looking way ahead, we're going off grid. Our systems are going to operate off grid in a period of time. I don't want to put a number, a year around it, because that's the kiss of death. But our vision is to go off grid. So we will set up textile dyeing solutions, digital textiles dyeing solutions that will not use any energy from the grid. So that's one dramatic progress that we're on our journey to achieve. We're just about to launch in the very near term a product we call Discovery, that is all about replicating the production properties of Endeavour. And the reason we're doing that is manifold. One is that you can do all your formulation and creating your recipes in color library data. So you build up a whole library and you can just run something on this small lab machine and it will translate and transfer to production exactly. And so there is no, we're maximizing our productivity and uptime. So that's one reason. The other reason is we're selling this Discovery to people who just want to get and understand the technology. And I think it's very important that we put this technology in the hands of as many people as we can if we're really interested in making these changes. So Discovery is pretty much ready for launching now. It's pitched at a level that should be acceptable to pretty much the industry. And it's an opportunity to play with the technology, see what opportunities you can use this technology for that maybe you couldn't use with traditional processes. You can validate the savings we claim, the LCA data, the economic data through this lab machine, and you can build your library of colors very quickly. This industry in the past has taken 50 years to evolve and produce formulations in color data. And this system is all about producing that very quickly.
Brilliant. Just because you've mentioned LCA, someone's just messaged me saying one last question. Do you have any LCA case studies that they can tap into either on your website or you could share some?
We're in the process of being able to do that. So the LCA data is very, very important. It's also very important to have production data, not data you create in the lab. That gives you an indicator, but everybody's interested in production data. So it's an ongoing process. We're in the process of releasing production data shortly, next few months maybe. And that will just be kept being updated as we get more and more experience of production data in the marketplace.
Okay, brilliant. With that, we'll wrap up, Alan, because we're just on time for the next session to start in 15 minutes. So thank you so much.
Thank you.
I would request our audience to join us back at 12 p.m. UTC, where we'll have a panel session on reinventing the dyeing and finishing for a net zero transition. See you all then. Thank you.